Question number 8. RCOCH3 can be reduced to RCH2CH3 by the option 1 that has been given over here is lithium aluminum hydrate, B, phosphorus under the presence of hydrogen iodide. Third option is zinc amalgam under the presence of concentrated HCl, and the fourth option over here is the hydrazine under the presence of a base that is the sodium ethanol. Okay, so ethoxide. Now, in this case, we need to select, as all the options says that there are possibilities of 3 of them which have a tendency to reduce RCOCH3. Okay, if R is equal to H, that becomes an aldehyde in this case. All right, so now if we have as R, C double bond O, CH3. Now this is what we are trying to reduce to R, CH2, CH3. This is what we are looking forward for, right? Now, if in case if R is equal to hydrogen, then it becomes as an aldehyde, right? Or if R is any of the alkyl series or an aryl series, then we have it as a ketone. Anyways, we require, in order to convert either it is an aldehyde or a ketone to a simple hydrocarbon, right? So here, if we observe the first case, that is a lithium aluminum hydrate. Okay, so the lithium aluminum hydrate, it's a very good unselective reducing agent, we can say. Okay, so it is an unselective reducing agent. Now this one really acts when we have a C double bond O, a polar C double bond O, either in an aldehyde or in a ketone. So in short, it is going to help us in order to convert an aldehyde or a ketone, okay, to an alkane. It will help us. So therefore, yes, this one is correct. Now, on the other hand, we cannot use phosphorus under the presence of hydrogen iodide in order to reduce the system. So this one is not actually possible to be used. When we observe the second condition over here, that is the zinc amalgam under the presence of concentrated HCl. Okay, now this one is actually a Clemenson's reduction. Okay, so therefore, Clemenson reduction. Now, as Clemenson's reduction also is going to help us in order to convert an aldehyde or a ketone to alkanes, right? While when we observe, that means even this one is a correct one. Okay, so therefore, even option C is going to help us. Let's observe N2H4. That is going to be the hydrazine under the presence of a base, as the base what we have taken is a C2H5O-Na. Okay, so therefore, when we have this hydrazine in base, hydrazine that is N2H4 under the presence of a C2H5O-Na. Okay, now this one is a Wolff-Kishner reduction. Okay, so the Wolff-Kishner reduction. Now again, Wolff-Kishner reduction helps us in order to convert an aldehyde or a ketone to alkanes. So basically, if we see, it is even the option 4 seems to be correct. That means we have the possibility of option 1, option 3, and option 4, which seems to be a correct answer. Thus, if we observe, it is going to be the option B over here, which says of all these 3 points. Thus, option B is the correct answer.